you so much, everybody. I see people joining. We are recording the session, so you can see the full recording after this meeting. Thank you so much for joining. It's super promising to be able to consider how we can use artificial intelligence and machine learning and Python and TensorFlow in order to detect threats affecting IT systems, services, assets, anything that we need to predict that there is a risk, or we want to organize in different categories segmentation in order to focus our attention. So welcome everybody. I see a lot of people joining, and it's a pleasure to be here another year. And let me share my screen. You will be getting a presentation. We are going to see a demo. So how these models are actually working. Let me. For some reason. I cannot share. I cannot move the presentation. Here we go. Let me come back. Now you should be able to see the screen. So let's start. Why we need artificial intelligence when it comes to cybersecurity? And there is a huge attention on this topic, and everybody now is an AI guru. Everybody is working on this, and we are seeing a lot of solutions and consultancy services in order to detect threats. So let me be very clear and on the three main use cases that we can today, with the technology that we have today and the knowledge that we have today, use particularly machine learning and random forest and neural networks are very promising in terms of technology here. There are different ways that you can teach an algorithm, a software, empowering you to foresee what is going to happen. And the main use case here is to detect threats. We can look for data that is coming in the log, using user monitoring, activities, network traffic, behaviors, in order to anticipate that a risk will materialize. That there is an attention to some activities, to some assets, to some services, to some third parties that we need to analyze, or we can automatically assign a flow. For instance, if I detect that there is an unusual activity in the user traffic, I am going to disconnect that user. I am going to confirm that the user is the one that I think it is. So you can get your attention, or you can automatically assign a flow, a control, a task to that insight that is being the output for an algorithm. You can also use artificial intelligence quite effective here in cybersecurity when it comes to anticipate vulnerabilities and losses. If you know that there is an incident on a particular type of asset, you can classify all the other assets, look what is similar to the one that you got the incident, that you can have the loss, and to ensure that you are considering the whole picture when it comes to a remediation plan. For instance, imagine that you have a incompatibility error with an asset that is connected to your customer system. Good. How can you detect all the other connections with similar assets, with similar settings, with similar software running, with similar services for the one that you are detecting? And in order to contain and to prevent recurrence of the same incident, you can use machine learning because it's very good not only at predicting, it's also very good at classifying. So if it is an issue that you got in a piece of software, with a patch that you need to do, with a service that you need to improve, you can look for all the other assets that they are very similar to the one that already have a risk materialized. And another use case that is being used in my experience is coming from how we can improve services, how we can tell that there is a third party that is doing something strange in the system. For instance, I have a client that is supposed to be in Belgium, but is activating services and cameras and licenses in Russia. Is that compromised or not? So when it comes to how to monitor the flows, how to respond to those type of different services that are being required, you can use artificial intelligence in order to set the proper flows, the proper controls, the proper performance of the system to respond to that particular service that you want to optimize. Let me see if I am able to move here. And you need to understand what is under the hood. There are a lot of software, service providers, consultants, non-code solutions that are promising to do a particular type of work for you. My advice here is whether you are engaging with this type of third-party solutions and services, you always need to understand what is going on. You always need to be able to explain how these solutions are being decided on your behalf. In that way, I highly recommend you to understand, to use, to learn Python TensorFlow. It's one of the key libraries in artificial intelligence, very powerful. I use that library a lot. I also use other libraries like PyTorch and sklearn. But when it comes to prediction, when it comes to integrating the services and the decision making into any piece of software in a flow manager that you got, Python is super powerful in order to support any type of recoding, refactoring, in order to integrate that engine into your system and to optimize. It's really very fast, and the services and the resources that they are being consumed by Python TensorFlow are already the best that you can get in order to make the process fast and light. I already anticipated that you can use two different types of techniques here that they are the ones that are promising. In fact, when you got a use case and you are doing your feasibility analysis and you are checking what you can do, the typical approach here is to solve that problem with different type of approaches, techniques in machine learning, and then you select the one that is better predicting what you want to explain, consuming the less resources. So you do a balance. This technique is very fast and it's quite good, but I also got this technique that is quite accurate, very accurate, but it's super slow. So even though this one is better, I'm gonna go for the fast one. And usually, we are choosing two different techniques. Supervised learning, particularly random forest, that is really working very well when it comes to risk data, incident logs, reports. They're usually missing some metadata, there are inconsistencies. Because of how this technique is working, like it's a big voting system in which there are different decisions that they are being made according to the information that they have. And even though one, two, or three of these decisions are wrong because the data is inaccurate, as an overall, because it's a very democratic system, it's going to choose the one that is more voted, it's going to be accurate. Even though some data are missing or are wrongly classified. And then another one that we are always using a lot in cybersecurity is unsupervised learning. Neural networks are extremely powerful when it comes to anomaly detection, whether it's user activity, system activity, network activity, they work so well. So they require more extensive training. We want to see that today, but they are quite strong. When it comes to one of the concepts that is that everybody is going bananas right now is how we can adapt security to detection and declassification. It's very fluid the way that we are controlling. It's not a process, an SOP that we are always following the same rules here. It's extremely dynamic, and we are calling that concept adaptive security use cases. For instance, in cybersecurity, what we are covering as a use case, network instructions, insider threat, data filtration, compromised accounts, they are super very accurate algorithm that you can use in order to detect there is a new threat affecting your system or data is moving in a way that never happened before. We are also using adaptive security for spam filters, for filtering phishing emails, and also to identify vulnerabilities. If we identify that there is an asset with a particular need for a patching, or there is a particular configuration that we want to improve, we can identify other assets that they are in a similar circumstances that the one that we know that there is a risk or there has been an incident already. And finally, we are also using machine learning for classification. Sorting asset, user services, tickets, priorities, focusing on the right third parties are extremely also good cases for adaptive security. So let me show you one example on how it's working. We are going to use Python TensorFlow, that is the library open source that they can accommodate artificial intelligence for unsupervised techniques and supervised learning techniques, neural network, to identify unusual patterns in network traffic. We have logs, we have data flows, and we want to tell what is normal and what is not. We are going to train a model. We are going to do 150 interactions. the more interactions that you are using for this type of learning, the better. But it takes more time and more resources. And we are going to look for something that is really looking different. We are going to focus on activity that is at least 50% different in terms of the sensitivity to other normal flows. And we are going to use bandwidth consumption, usage, servers in and out, and data transfer size, how big is the size. This is a dummy data from different IP addresses, the traffic protocol, the timing, transfer size, bandwidth, all of these are here, and the port that is being used. So even with a naked eye, you can identify that there are activities that they are consuming more data on particular days, that they are not work days, and they are very large. So even though you don't have any type of machine learning here, basically you can identify with a naked eye that there is something wrong here. Let's check how this model is going to work. So we are going to use neural networks. We are going to cover 6 different features. We are going to add 5 layers in TensorFlows. We are going to detect activity that it will be abnormal or normal. This is the thing that we are going to do. All these settings in terms of the configuration of the learning, they are called hyperparameters, and this is the one that we are always improving and optimizing in order to train Python on a very solid ways that they can provide a good insight. There are a lot of metrics that we are using. So let me go here, 1 second. Let me move here and go to the model. You should be able to see my screen, and then we can move to the questions here. So this is the code. Let me know if you want to use this code. It's already in the presentation, but I can give you the GitHub link if you want. And this is the data. You can connect the data to the activity log, or here I just extracted the data and I put here just as an example. Then it's going to create the flows, it's going to normalize the data, it's going to encode the data to be sure that the values are put on the same scale, and it's going to train the data. Look at how easy is to code in Python. It's really very powerful. It's just few lines of code that you can teach your model in order to detect what's usual or not. Then there are some type of controls. We usually select a subset of the data in order to ensure that it's accurate or not. And finally, it's going to display the data transfers that they are not normal, that they don't follow the pattern that we expect. Let's see how it works. This is Google Colab. Now the model is start learning. We are seeing the different interactions. I say 150. Why 150 is because this is the lowest number of interactions that they can produce data that is very meaningful for me. So you need to play with these parameters, hyperparameters, in order to get something that finally is optimized. How we can tell that it's optimized? Because the value for the loss between the prediction and the reality, as I say, there is a subset that's being used for testing, is being reduced. The more that the model learns itself from the data, the less that we have losses. So it's learning and it's becoming more accurate. There is a moment in time that the learning is not really improving the model so much. It start getting to the same level, and this is when we stop. There are different techniques that we can use. We use many of them, and okay, I say this is for me the lowest that I can have in terms of the loss is perfect for me, and it's detecting, of course, cryptocurrencies. So I can tell from the log that is one server that is farming cryptocurrencies. I see a traffic that is not usual on the date is not usual, the size is not usual, the port is not usual. So I will say that this um, server is compromised by farming malware. You cannot do that manually. You cannot tell manually how it's working. And this is the code. The code is quite direct, quite easy to manage, and you can improve it in time because, of course, the more that they are learning, the more that this model tends to drift, and they may have wrong data. They may, of course, if somebody wants to jeopardize those services, they want to poison the data in order to prevent you to detect that there is something unusual. There are many risks here because we need to learn in cybersecurity today not only how to use artificial intelligence in order to reduce the risk and to focus the controls. We need to be able to learn how to assess risk based on these models, on AI-based software. We need to assess control for this risk. And let me tell you, the scenario, the threat vectors, the vulnerabilities that I am facilitating and assessing when it comes to AI are completely different from cybersecurity. Some of them, they have some relationship when it comes to the robustness and the security of the AI models, but some of them are completely different. And we also need to assess what is going to be the impact on the third parties, and there are a lot of impact, vulnerability assessment, many different techniques that in risk management, in controls, in compliance, we need to focus our capabilities much better when it comes to artificial intelligence, because it's reducing the risk for the general software and asset, but it's also changing the profile in which, of course, any type of adversary is going to try to attack these models because they can bypass many controls and decision making and commit any kind of attack. So AI is a way to control risk, and AI is also posing different type of risks in terms of cybersecurity and IT and services. Besides, it's a completely different way of thinking. So this is the model. You can get the presentation, and I am super welcome to connect you on Twitter or LinkedIn. I am sharing a lot of presentation and classes, and without prescribing any type of particular technique here, just overall, and super eager to share that knowledge and code. When we decide the type of technique that we are using, we usually consider different approaches, and we select the one that is better fitting the use case. After that, we check how they are working and the metrics. We make sure that the business understand that this is a way that they have 5%, 1%, false positive, false negatives, depending on the risk that they are quantified, always quantify the risk. Saracen is very strong on this. You cannot uh, produce in a type of corporate defense if you can tell that you are not controlling because few people in a room decided it was a green risk or a one by one risk or a non-catastrophic risk because they don't have any meaning. You need to really look at data when it comes to risk and quantifying cybersecurity risk using molecular simulations, convolutions, log normal, Poisson, in an easy way that they can be related to the cyber insurance and the type of controls are also extremely relevant when it comes to artificial intelligence. This is one of the key areas in cybersecurity now, how we are quantifying AI risks in order to ensure that the metrics that these models have are correct. So let me see if there are questions. I see two comments in the chat. Cryptocurrency protocol is asked by Ricky Caballero. Yes, any type of a cryptocurrency protocol. I am just simplifying the case. I don't know, Leo, what is off. I think that it should be fine the way that you are connected. Any other questions from the audience? We have 2 minutes to go. Otherwise, thank you again for the invitation to CyberScience in order to share these practices. This year with AI, that is a very hot topic in cybersecurity and consulting right now. We need to get a lot of new tools and approaches and real experience here in order to commit all the good principles and all the hype that artificial intelligence has in business. On the other hand, we need to be able to be laser focused on the use cases and what are the return of investment when it comes to this software. And it really requires a very specific knowledge that I am super happy to exchange tools and share tools and to get discussions about how we can protect our societies better. So if there are no other questions, I think that we can finish the session today. It was half an hour. It was very focused on this demo. Regards from Copenhagen, Denmark, and see you soon.